Hello students, welcome to the IMS Gate Academy, and I welcome you all over the session that has been already conducted a way week before, isn't it? So yeah, we have completed around a lot of subject with respect to the important concept, and as you know that we had started with the electrical machine, and we have seen a quite number of important topic which we had already covered. Okay, so as you know that I Nikhil Gaurav basically we had seen a concept related to the electrical machine, basically the chapter transformer, induction machine, and the DC machine and synchronous machine are left over. So like in this particular lecture we will going to study with the important topic which is in the synchronous machine. Okay, so let me take you to just a second to the today's session that we are having, which is with respect to the droop characteristic. If you see here, this is the droop characteristic in the synchronous machine, and this is very important topic. Okay, like if you have already seen the past year question from the gate, that is from the electrical stream, definitely you will see like in a consecutive year you may going to find a question related to this particular topic. Now why this particular topic is very important? Anyone? Okay, so see before going ahead, one request guys, please do share the session link with your friend, and please inform them that the classes has already started. So please join as quickly as possible so that we are going to have the wonderful session over here. All right, now my question is why this particular topic is important and why it is need to be studied. Like in 2012 you might have seen you might have heard about the complete blackout, isn't it? Blackout is what? Basically the complete shutdown of the power system. So basically in the synchronous machine, or basically in the power system, you might have seen that the power is basically going to be transmit in the form of electrical. Okay, basically the mechanical power is going to be generated and the electrical power is going to be transmitted over the via the cable or via the overhead line, isn't it? But how those power is going to be generated? So the power is going to be generated by the synchronous generator. So suppose you are having one particular generator which is generating the power of 100 megawatt. So basically that 100 megawatt generator is going to deliver the load. Let me take a full load as a 100 megawatt. What if the power is going to be extended? Like suppose if the power is become 200 megawatt, then what, like whether the synchronous generator is going to supply those particular load? Is it possible? No, it is not possible. So what we will going to do? We will going to put, or we will going to insert one more synchronous generator in parallel to the existing generator, so that we are going to supply the increased load or increased demand. Gopal Rao, good evening Gopal. So yeah, so this is a brief about how the power is going to be, or how the energy is going to be, or you can say how the demand power is going to be supplied by the synchronous generator. So it is very clear that whenever the load is going to be increased, then my prime task, or it is a prime task of the generator to supply those particular load. Got the point? All right. So in practicality, the synchronous generator that we are having not limited to 2. It is more than 5, 10 and so on and so forth, because right now we are having the demand not in megawatt also, even they are having in the gigawatt. So basically this is not possible by a single synchronous generator to supply such huge amount of power. So because of that we are going to connect a synchronous generator in parallel. Okay, so while you are going to supply those particular load and also while inserting the synchronous generator in parallel, certain criteria has to be fulfilled, just like in your transformer. Like see, in the transformer we have seen that we cannot randomly put a transformer in the parallel. Certain criteria has to be fulfilled. What is that? Voltage rating has to be equal of all the transformer. Similarly, turns ratio, polarity, and phase displacement, and so on and so forth. If all those conditions are going to be fulfilled, then only you are going to put, or you will going to place the transformer over the existing transformer. Okay, so this is basically in the transformer part. So in this way, there is a condition related to the synchronous machine for the parallel operation. And what is that? If the, like suppose you are having the good number of synchronous generator which are existing, okay, in a parallel to supply the particular load. So for all those particular generator, what you are going to have, the frequency has to be same, and also the voltage, the terminal voltage has to be same, and also the speed, or the speed of the rotor of all the synchronous generator which are existing has to be same. If any of the generator is violating any of these three conditions, then there will be a complete shutdown of the power system. Got the point? So this is basically a general idea. Now assuming that you are having n number of synchronous generator which are existing and supply a particular load. Now if the load is going to be increased, then what is going to be happen? What is going to be happen? Any idea? No? Okay, let us see by using the particular dynamic equation of the machine. Okay, so let me write here J d square del by dt square plus B, or okay, del divided by del means a partial derivative of a load angle with respect to t. Next, K del, or what should we write? Okay, let me write in terms of speed, or simply this equation by ignoring all the other term. Okay, this should be equal to or plus load torque, this is equal to prime over torque. Okay, so this is the dynamic equation of your generator. Okay, what if the dynamic equation, if you want to write in case of motor, then you need to switch, or you need to swap these two particular terms. Okay, so this is the dynamic equation of your generator, where TPM is the mechanical torque, or it is better to write in terms of power. ठीक है, मैं power के term में लिख दे रहा हूँ ताकि वो easily समझ में आ जाए. So let me take electrical power, this is equal to mechanical power. So this is the dynamic equation. Let me shift the power to that side. So J d square del by del T square, this is equal to mechanical power minus electrical power. So what condition I told you, that for all the synchronous generator, the frequency, speed and terminal voltage has to be constant. Otherwise, if any of the thing is going to be violated, then there will be complete shutdown of the power system. So see, as I told you, let us increase the electrical power or load, and the mechanical input remains unchanged. Then see what is going to be happen. Let PE increased and mechanical input or mechanical power remains unchanged or unaltered. Then see what is going to be happen. Okay, so J d square by del with respect to t, this will be less than 0. Why, sir? Because as I told you, your electrical power, which is the load power, is increased, but PM remains unchanged. Then by using this equation, this will going to be decreased. Now as we know that partial derivative of speed is nothing but partial derivative square of del. So substitute this value here. See what is going to be happen. D omega by dt, this is less than 0. So from here I can say that omega is going to be decreased. So this omega is nothing but the synchronous speed of the particular generator. or this speed has to be same, like this omega has to be same for all the synchronous generator. So what is going to be happen if synchronous speed is nothing but, am I audible? Please confirm. Okay, chalo. Now see, as I told you, your omega s, this is speed of the rotor. Okay, your omega s, which is nothing but 120, okay, sorry, 2 pi ns by 60. So if omega s is decreasing, this implies synchronous speed is also going to decrease. Now synchronous speed, which is nothing but 120 f by p. So ns is proportional to f. So since ns is decreasing, this implies your frequency is going to be decreased. So this point I already written over here. So whenever this frequency is going to be like if it is going to be down to some certain value, like say suppose if the power system is operating earlier at 50 hertz, and due to this down of the speed or decrement of the speed, if the frequency is going to be decreased to far below than the 47.5 hertz, which is a certain limit for the power system to run. So after that, the complete power shutdown will going to be occur, and this situation should not have to be arise in any particular situation. Got the point? तो हमें ये कोशिश करना है कि ये फ्रीक्वेंसी 47.5 हर्ट्ज, इफ योर रेटेड फ्रीक्वेंसी इज 50 हर्ट्ज, देन उसके नीचे ये ना जा पाए, अदरवाइज कंप्लीट शटडाउन होगा. In the same way, I have taken the case for the increment of the load. You can also take the case for the decrement of the electrical power. So in that case, the speed is going to be increased, and similarly, the frequency is going to be increased. So if it is go beyond the 42.5 hertz or 43 hertz, then again your power system is going to be shut down, because as I told you, for the parallel operation of generator, frequency, speed and terminal voltage has to be same for all the generators. Okay, so like see, this can be studied, this particular thing can be studied by the term which is known as Droop characteristics, which is known as Droop characteristic. Now look at here, what do you mean by Droop characteristics? Okay, so this is the curve, like this is the curve between the frequency over the power. Okay, which power, electrical or mechanical? Electrical or mechanical? It is electrical power. Okay, so let me take a frequency f at no load. So this is the frequency at which the load is not connected, then whatever frequency we are getting is no load frequency. Ideally for zero load, for full load, or for any kind of load, the frequency should be this. But as I told you, when you're going to put a load over the synchronous generator, then frequency is going to be decreased because speed is going to be decreased. So see the curve. Just a second. Okay, so this is the basically a line you will going to get when you increase the electrical power. So as we know that the frequency is going to be decreased. So let me take this frequency as f rated, this frequency for a particular kind of load which is having the p rated. समझ में आया मैंने क्या बोला? So कोई भी particular load आप दे दो synchronous generator में, for all kind of load you are going to have the frequency less than the no load frequency. So basically this slope is nothing but known as a droop characteristics. It is known as droop characteristic. Okay, so basically from here droop is equal to change in frequency from no load to full load or rated load. Let me write FL, full load. Now, this value is nothing but rated frequency or full load. This is also power at full load. Done. Divided by P rated. Okay, here I have considered a mode. Please do not think that, sir, from here you are going to get the positive value. So how you are saying that it is a down slope? So here I have taken the magnitude. Okay, but actually this is a minus of P rated ना, समझ में आया? बस एक एक्सप्रेशन लिखने के लिए मैंने वहां पे उसको एज अ मैग्नीट्यूड समझ लो वहां पे, ठीक है? सो दिस इज नथिंग बट द ट्रूप ऑफ द पर्टिकुलर सिंक्रोनस जनरेटर. नाउ आइडियली व्हाट हैज टू बी हैपन? आइडियली if you increase the load, the frequency should not have been decreased. So this is the ideal characteristic of any particular synchronous generator. But as we know that it cannot be possible because of that dynamic equation. Got the point? Any doubt in this? Any doubt in this? Done? Clear hai? Okay. One more thing, like in instead of P rated, we can also use the frequency as the base value. Okay, frequency as a rated. Now this rated can be in terms of no load and full load. Please do not think that F rated means the full load. Okay, here F rated, why I have written, because in the GATE exam the frequency, the base can be taken as a full load or it may be a no load. So depending on the question, depending on the GATE problem, you will have to see whether the frequency is dropping from no load to full load or it is increasing from rated to full load. So depending on that, this value is going to be changed. Okay, so F लिख दूं क्या या फिर क्या लिख दिया जाए? चलो F ही लिख दो. Okay, so depending on, let me change the color. Depending on base of frequency the frequency F can be written in two ways. So you have to carefully watch whether the frequency is from no load to full load or full load to no load. So if frequency is from no load to full load, means the change in frequency. If in the question it is given that the frequency is from no load to full load, then F is equal to F no load. Means in denominator you will have to take the no load value. Okay. Second, this F can be written as from full load to no load. Then F will be taken as a full load. So it is better to write a reference instead of this base. Okay, let me write a reference here. Okay, so this is nothing but your droop, and if you replace the frequency with respect to their speed, you will going to have the droop with respect to speed. Got the point? Okay, now let us come to the parallel operation. As I told you, the single synchronous generator cannot supply the rated load of the power system. So we will going to have more than 2 or equal to 2 generators. So let me take a general case of the 2 generator so that we can understand the thing very carefully or very clearly or in a lucid manner you can say. ठीक है, प्रैक्टिकल में 2 से ज़्यादा यहाँ पे सिंक्रोनस जनरेटर होंगे, बट समझने के पर्पज से मैं यहाँ पे 2 ही जनरेटर लिया हुआ हूँ. Now, as I told you, this 2 generator, okay, see here, this is generator 1 and this is generator 2. Please do not think that this is the generator 1 axis, So take this generator 1 value, the power value here as positive, then for generator 2 or for the generator 1 it will become negative. ऐसा नहीं है, यहाँ पे generator 1 का power ले रहा हूँ और this side में generator 2 का power ले रहा हूँ, and this is your frequency. Got the point? Now this particular 2 generator is going to supply a load. Let me take PL equal to P1 plus P2. Let me take equation 1. Now what is this? What is PL? So PL is the load, P is the electrical power which is supplied by this 2 generator. So in the question, like in the gate problem, you are going to have the 3 kind of questions. They will going to tell you that give me the values for P1 or P2. Like see, the 2 unknown is possible. Like here basically not 2, 3 unknown. In the gate problem, they may going to tell you that find P1 or P2 or the frequency at which they are going to operate. So which frequency here? This frequency. Means for this particular load, what should be the frequency at which this 2 particular generator is going to operate? That we need to determine. तो समझ में आ गया? तो 3 क्वेश्चन यहाँ पे बन सकते हैं. Either they will tell you to find P1 or P2 or this unknown frequency or common frequency at which this 2 particular generator will going to operate to supply this load. Okay. So see, this is the generator 1, where for the generator 1 this is the no load frequency, and at the rated value of the generator 1 the frequency is this. Done. And this is the droop curve for the generator 1. Okay, this straight line. Similarly for generator 2, this is the no load frequency for the generator 2, which is FNL2, and the rated value of the generator 2 will give you the frequency at full load, or the rated frequency for the generator 2, which is FL FL2. Got the point? मैंने क्या बोला? Generator 1 के लिए no load frequency यहाँ पे है. Similarly for rated value और full load value के लिए frequency यहाँ पे है for generator 1. Similarly for generator 2, no load is here and full load frequency is here. So it may be like this no load frequency can be equal. If nothing is specified in the question, then we will going to assume the no load frequency to be equal. तो आपको question में देखना है whether the no load frequency are given separately for the 2 generator or not. If they have given, then we will have to take it as separately. Otherwise, if they have not given, then by default we will have to take this 2 frequency as equal. समझ में आ गया? Now let us have the equation P1 at which they are supplying this load and generator 2 supplying this P2 load. तो मुझे ये दोनों find करना है. And as I told you, if they are going to supply a load, they will have to operate at particular frequency, and this is that frequency which I need to be find. Okay, तो कैसे find करें? If you see carefully, you are going to have a triangle. For come to the right hand side. Okay, come to right hand side for generator 1. You are going to have this particular triangle. Let me take O. This is A, this is C, this is D, and this is B. Okay, so from triangle O A B, okay, ये triangle को देखो O A B and triangle O C D. These 2 triangles are similar क्योंकि इनके angles क्या है? These angles are equal. So whenever angles are equal, then the triangle are said to be similar. Okay, all right. So what is tan theta for this particular triangle OAB? FNL1 minus F divided by, this is 0 power minus F1. तो मैं यहाँ पे लिख रहा हूँ for generator 1. So F no load 1 minus F at which they are operating divided by minus P1 from the छोटा triangle. Okay, from the छोटा triangle. Now come to the bigger triangle. No load 1 minus full load 1. No load 1 माइनस फुल लोड 1 डिवाइडेड बाय माइनस P1 रेटेड। समझ में आया मैंने क्या लिखा? दिस वैल्यू, ठीक है। PFL1 लिखा है तो मैं इसको PFL1 कर देता हूं यहां पे, PFL1। सो फ्रॉम हियर यू आर गोइंग टू हैव दिस P1 इक्वेशन। कैसे होगा? P1 इज इक्वल टू F नो लोड 1 माइनस F डिवाइडेड बाय दिस वैल्यू, F नो लोड 1 माइनस F full load 1 times this value, PFL1. So this is equation 2. So let me inbox the formula. Okay, and the first one was here. Okay, now similarly for this particular triangle, इसको देखो O A and B डैश, तो ये क्या होगा यहां पे? इसकी बात कर रहा हूं। ओके, इसकी बात कर रहा हूं मैं, जस्ट अ सेकेंड। इस पर्टिकुलर ट्राइंगल की। सो नो लोड 2 माइनस F डिवाइडेड बाई दिस वैल्यू। ओके, so F no load 2 minus F divided by minus P2, this is equal to, now बड़ा वाला triangle, this one, F no load 2 minus F full load 2 divided by minus P full load 2. Look at here, this one. ठीक है? Now from here I can get P2 value or P2 expression basically. So F no load 2 minus F divided by F no load 2 minus F full load 2 into P full load 2. Let me take this as equation 3. Just a second. Okay, so this is your equation. So how many unknowns we are having? Unknown frequency, P1 and P2. So 3 unknown, 3 equation, 1, 2 and 3. We can easily solve all the unknown quantities or entities. So इस way में if you are going to have the question related to the parallel operation, you will going to use this 2 equation along with this load wala expression. Okay, now let us understand this concept with the gate problems. So here you are going to have the first gate question which was asked in gate 2022 for 1 marks. Okay, a single phase 50 Hz synchronous generator on Droop control was delivering 100 megawatt power to a system. Due to increase in load, the generator power had to be increased by 10 megawatt. As a result of which the system frequency dropped to 49.75 Hz. Further increase in load in the system resulted in a frequency of 49.25 Hz. At this condition, the power in megawatt supplied by the generator. Okay. So I need to calculate the power in megawatt if the frequency becomes 49.25. Now as we know that if the load is going to be increased, the frequency is going to be decreased. So if you see carefully, you are going to have the Droop curve. So this is frequency, this is power axis for the generator. How many generator? Okay, only one generator, so generator. Okay, so at 50 Hz, this is 50 Hz, this is 50 Hz. Okay, sorry, at 50 Hz, due to increase in the load, the frequency is going to be decrease like this. So let me take this frequency and one more. Okay, so this is 49.75, 49.75, this particular frequency. Okay, and this frequency is 49.25, and here you have a load as 100 megawatt. Okay, so let me write here megawatt. This axis is in megawatt. Now, when you have a frequency of 49.75 hertz, then your load was increased by 10 megawatt. So, what is this value? It will be 110. ये समझ में आया क्या हुआ? अगर आप 10 वॉट से इंक्रीज किए हो तो आपकी फ्रीक्वेंसी 49.75 हर्ट्ज हो गई. नाउ व्हाट शुड बी दिस लोड? लेट मी टेक Px. What should be this load such that frequency becomes 49.25? Now, this question can be solved directly by looking into the gate problem. I can say that for 0.25 change you have 10 megawatt, then 0.75 you will going to have 30, 110 plus 30, 130 मेगावाट इज द करेक्ट आंसर. ठीक है, मैं बताऊंगा कैसे हुआ डायरेक्टली, पहले इसको समझो यहाँ पे. ठीक है, so I need to calculate this Px value. Now it is very simple. See, this is nothing but your trigonometric question. So this angle and this angle are equal. So this triangle, छोटा वाला triangle and this bigger triangle are similar. So can I say this frequency, change in frequency divided by this power? तो कितना हुआ? 50 minus 49.75 whole divided by 100 minus 110. Okay, ये ट्रायंगल की बात किया मैंने. सो फ्रीक्वेंसी माइनस पावर. नेक्स्ट लेट मी कंसिडर दिस बिगर वन. 50 minus 49.25. 50 minus 49.25 whole divided by 100 minus Px. जरा बताओ कितना आ रहा है? दिस इज 0.25 divided by minus 10. This is equal to, this is 0.25 divided by minus 10. This is equal to 0.75 100 minus Px. तो ये कैंसिल हो जाएगा, यहाँ पे 3 होगा. सो 100 minus Px. Okay, take this to this side. 100 minus Px, this is equal to 3 minus 10, so minus 30. समझ में आया कैसे हुआ? Okay, minus 30. So from here Px is equal to 130 megawatt. As simple as that. बहुत easy था, बहुत easy था. Just you need to like make a Droop curve, and from there you are going to have your answer. So the question is very simple, which was asked in GATE 2020 for 1 marks. Now how I have given the answer within a like you can say in a few seconds. How I have given? See, at no load or at 50 hertz, what is the power? 100 megawatt. And by the like if the load is increased by 10 megawatt, what was the frequency? 49.75 hertz. So can I say 4.25 hertz change in frequency? What is the change in power? 10 megawatt. So this is the direct method basically ना, जो यहाँ पे मैं लिख रहा हूँ अभी. This is the direct method. Okay. So from the figure we know that for 0.25 hertz, it will give you power as 10 megawatt of change. ठीक है, change in frequency divided by change in power. So this is the 10 megawatt. ठीक है, और हमें पता है 50 हर्ट्ज पे the power is 100 megawatt. तो ये समझ में आया, मैंने कैसे लिखा, 50 minus 49.75. This minus this. Now, if the frequency is changed to 49.25, then what is the overall change in frequency from 50 to 49.25? The change is of 0.75 hertz. Then in this case, what will be the change in power? What will be the change in power? So see, for 0.25, you are having 10 megawatt. So when you multiply this with 3, just a second, when you multiply this equation with 3, so what you will get, 0.25 into 3 will give you 10 into 3 megawatt, which is nothing but 30 megawatt. Done. So at 50 hertz, what was the power? 100 megawatt. So for 49.25, for 49.25, add this value. So what you will get? Power at 49.25 hertz. So this is equal to 100 plus 30, which is 130 megawatt. In this way, you can easily solve your gate problem. Okay, so for such kind of problem, you please do not pick your pen and paper in the gate exam, because as you know that you are going to have the scribble pad. So you are going to have overall 12 pages, so overall 24 sides. So you are having a limited amount of space to cover all the gate problem, that is 65 question. तो हमें पेज बचाना बहुत ज़रूरी है. सेव द टाइगर जैसे होता है वैसी तरह सेव द पेजेस. ठीक है. So in this way we will going to find directly without picking your pen and paper. Okay, let us come to the last question which was asked in GATE 2017 in EE. Two generator units are 300 megawatt and 400 megawatt have governor speed regulation of 6% and 4% respectively from no load to full load. So this is basically reference. Okay, so this no load is the reference. Both the generator units are operating in parallel to share the load of 600 megawatt. Assuming free governor action, the load shared by the larger unit. So what is this governor action? What do you mean by this governor action? Governor action is here, it means that the frequency if it is decreasing or the speed if it is decreasing, then who will going to increase that? It is been done by the governor. So देखो जैसे मैंने लास्ट केस लिया था ना, the increment of the electrical power, then the speed is going to be decreased, but ideally the amount of increment of the electrical power has to be cope up with the amount of increment of the mechanical power. तो वो कैसे होगा? By injecting more amount of steam over the turbine. If you're going to inject more amount of steam over the turbine, then the turbine is going to be rotate at a faster speed, therefore the frequency is going to be increased. तो ये किसका काम है? गवर्नर का, जिसको बोलते हैं स्पीड गवर्नर. ठीक है. So in the same way, if the electrical power is going to be decreased, so at the same time mechanical power is going to be decreased. So the speed governor will going to close the valve such that a limited amount of or a less amount of steam will going to hit the turbine, such that the speed is going to be slow and the frequency is going to maintain at a particular value. समझ में आ गया? So that is nothing but the speed governor or frequency governor. Okay, तो यहाँ पे कैसे होगा क्वेश्चन? So let us take the first power P1 as 300 megawatt and frequency is given. क्या frequency दिया गया है? नहीं. So let us take the no load frequency as क्या ले लें? FNL. ठीक है, FNL. So this is nothing but the rated value for generator 1. And one more thing, the droop is given for the generator 1 is 6%. So droop is given as 6% from no load to full load. This is very important line. Similarly, for the generator 2, so this is nothing but the rated value or full load value. Similarly, P FL2. This is 400 megawatt now for the generator 2. So 400 megawatt. And what is no load frequency? It is given. No, it is not given. So we will assume the no load frequency for both the generator to be equal. जैसा मैंने बोला था कि जब भी no load frequency नहीं दिया गया होगा, so we will going to assume no load frequency as equal for all the generators. Okay. So here this is the rated value for generator 2, and the droop is given as, for the generator 2, the droop is nothing but 4% from no load to full load. So if you're going to plot this all thing in your curve, see how it is going to come, So this is frequency, this is generator 1, okay. Let me take this as generator 2 and the power in megawatt. All power in megawatt. So यहाँ megawatt दिया गया है क्या? हाँ. All power in megawatt for the generator. Okay. So let us take this as no load frequency, which is FNL. Okay, so for the generator 1, the change in slope is what? 6%. So here for the generator 2, the slope is somewhat higher, comparable to 4%. समझ में आ गया? For generator 1, the slope is higher as it is 6%. Okay, so this is F full load 1. This is F no load 1. Okay, so when this is F rated की वैल्यू कितनी है? For generator 1, 300 ना? For 300 it is 6% and for 400 it is 4%. So this is change in frequency. This is PFL1, which is 300 megawatt. Okay, let me see 300. And what is the change in frequency? 6%. Means तो ये कितना होगा? जल्दी बताओ, ये कितना होगा? अगर 6% का change है तो, so this will be 0.94 F no load 1. समझ में आ गया? कोई डाउट यहाँ पे? क्लियर है? Let me take the second. As this slope is very less comparable to this value. Okay, let me change the color. Okay, this is the full load and this one is the no load. Okay, so this value is 400 megawatt. So let me take for P FL2, which is 400 megawatt. Okay, this is given as 400 megawatt. And this F full load 2. So change in frequency कितना है everybody? Change in frequency is 4%. So from full load to change in 4% is what? This value becomes 0.96 F no load 2. So this is nothing but we have assumed no load 2. Because no load frequency is not given, so we will assume same. So my task, okay, just a second. So my task is to calculate the load shared by the larger unit. तो larger unit कहाँ पे है? यहाँ पे है. So and anything else is given. Yeah, load is what? P1 plus P2. This is given as P1 plus P2 as 600. So let me take this as equation 1. Sorry, 600. Let me take this as equation 1. Okay. So I need to calculate this P2 value. So this generator will going to supply the load at this same frequency. क्योंकि अगर ये नहीं हुआ, then parallel operation will not going to be happen. Okay, just a second. Let me make it more straight. Okay. Okay. So this is P2 and this is P1. So this is P2 which I need to calculate, and this is P1. And this frequency is unknown frequency at which the both generator are operating. समझ में आ गया? तो मुझे क्या कैलकुलेट करना है? This P2 value. So this P1 plus P2 is 600 megawatt, which was given in the question. Now again the same thing. See this curve. Sorry, see this triangle. The first one, smaller one, and the bigger one. These two are similar. Then I can say that. This frequency F no load minus F no load minus F whole divided by कितना पावर है? P1 means और minus P1. This must be equal to, इसकी बात करो, because these two are similar. So F no load minus F full load. F no load minus F full load 1 divided by minus P full load 1. So what are the values that are given? F no load is unknown. Frequency at which it is operating, P1, that it is unknown. F no load minus F full load. So if you see carefully, from here to here, what is the change? So F full load is 0.94 F no load 1. So this is nothing but F no load minus 0.94 F no load 1, and no load 1, like F no load 1 is nothing but F no load divided by this value is 300. This is 300. Got the point? So let us have something over here. So यहाँ से P1 will be what? 300. Okay. F no load minus F whole divided by, ये वैल्यू कितना हो जाएगा? 0.06. This value is 0.06. So let me take 0.06 here. Divided by F no load. This is equation 2. कितना समझ में आया सबको? Now similarly equation or for the generator 2. For the generator 2. Generator 2 के लिए क्या होगा? F no load minus F divided by minus P2. This value, this is smaller one and this bigger one. This is equal to F no load minus F full load 2 divided by minus P full load 2. So F no load minus F, this will be P2, negative negative will be cancelled out. F no load minus, ये दिया गया था 0.94 F no load, because this value is 0.96 F no load 2, and no load 2 is nothing but the no load frequency which are equal. तो चलो देखते हैं. Okay, this is 0.96 basically, extremely sorry, this is 0.96 divided by this value is 400. चलो यहाँ पे देखो क्या मिलेगा. P2 P2 value will be 400 times F no load minus F this value, and from here okay, let me take this resultant value here 0.04. So F no load. ठीक है, so let me take this as equation 3. Now substitute equation 2 and 3 in 1. तो P1 plus P2 दिया गया था कितना 600 ना. So let us take P1 which is nothing but P1 कितना है 300 by 0.06, 300 by 0.06 F no load minus F divided by F no load plus 400 divided by 0.04 F no load minus F divided by F no load, this is equal to 600. तो यहां से कितना आ रहा है वैल्यू F no load माइनस F डिवाइडेड बाई F no load. कॉमन ले लो इसको, इस वैल्यू को ले लो कॉमन. सो हियर यू विल गोइंग टू गेट 300 डिवाइडेड बाई 0.06 plus 400 divided by 0.06 which is equal to 600. So this implies F no load minus F divided by F no load, this is equal to, जरा जल्दी बताओ कितना आ रहा है ये वैल्यू. Okay, let me calculate. So okay, sorry, this is 0.04 ना कहीं पे, हाँ 0.04. So 600 divided by, so 100 ऊपर चल गया तो 50 into 100 5000 ये आ रहा है, प्लस ये 100 into 100. So this is coming as 50 into 100 5000. Okay, just a second, मुझे कैलकुलेट कर लेने दो. 300 divided by 0.06, so this is 5000. 400 divided by 0.04, this is 10,000. हाँ, तो ये कितना आया है ये वैल्यू 600 divided by 5000 plus 10,000, this is 0.04. Okay, this value I am getting as 0.04, but my task is to calculate the power supplied by the larger unit. तो कितना है यहाँ पे larger unit, that is P2. Okay, ये P2 मुझे calculate करना है. तो P2 expression is what we have calculated ना, P2 value is 400 divided by 0.04. So let me write here directly. So power supplied by larger unit. So this is P2 400 by 0.04 into this value which is 0.04. So from here you will going to get 400 megawatt. Okay, so yeah, see, by the grace of the God we are getting the same value as a 400 which was given in the question. Okay, so it is not always true that you are going to get the 400. It may be less than 400 or the value basically depends on the load supplied. Okay, ये ऐसा हमेशा इक्वल नहीं होगा कि जैसे यहाँ पे क्वेश्चन में 400 दिया गया था, यहाँ पे 400 दिया गया था तो यही आंसर होगा. नो, कभी कभार ये वैल्यू चेंज हो जाएगा. बेसिकली दैट वैल्यू ऑफ लार्जर यूनिट, जो भी वैल्यू कैलकुलेट करोगे दैट डिपेंड्स ऑन द लोड गिवन हियर. ठीक है, सो या we are very fortunate that whatever value is given for the generator 2, the same value we are getting on calculating this particular load. ठीक है? So with this we have completed the today's important topic, that is the Droop characteristic. And yeah, this is very important. So whenever you are having any doubt, please, with respect to this topic, please you can watch again. Definitely whatever doubt you are having will going to be get clarified. Okay, all. So yeah, with this we have completed the important topic with respect to synchronous machine. So we are left with one more chapter, that is the DC machine, and in that we will going to discuss the speed control of the DC motor, which is the very important topic for the GATE exam. So yeah, we'll meet again on the next topic, which is going to be held on Friday, and those particular topic will going to be conducted in the part 1 and part 2, and we will going to discuss in a detailed manner. All right. So guys, please do share the session with your friend, with your the person those who are knowing you, or the person those who are going to give the GATE exam. Please share the session so that they also going to have the benefit of this particular session. And also press the bell icon so that whenever you are going to have the upcoming session just like this, so you will going to have the instant notification of that. And also for that particular thing, you will have to subscribe to our YouTube channel. So if you have not yet subscribed, please do subscribe, and definitely you will going to have the great advantage of all those particular sessions. Okay, so we'll meet again on the next particular topic, which is going to be happen on the Friday. Okay, so bye bye, and take a very good care of your health.